There are two main questions that we can ask to a reaction. When a reactant becomes products, the study of chemistry separates in two different kinds of questions. One question is how fast is this reaction going to be, which this belongs to the field of chemical kinetics. And the other question is to what extent it's going to become products. Okay, or is it going to become products at all? And this is the so-called thermodynamics and equilibrium. Okay, in this video we will very fast introduce some concepts that relate to how fast chemical reactions take place, or what factors do they depend on. So let me just introduce some questions here. For example, why is it that some reactions are slow and others are fast? This is something that we see in our daily lives. Why do we put food in the refrigerator? That is very much related to how fast reactions take place. How can the digestion of food happen in minutes if my sandwich was in a bag for hours, etc. Right? Or do chemical reactions stop, and if so, why do they stop? These four questions are the questions that we'll try to answer in this video. So let's just give some examples, giving a very common type of reaction, which is combustion. Combustion reactions are reactions with oxygen. And let me give an example. So a rocket, for example, uses hydrogen to react with oxygen, and that reaction is very fast. Actually, it's so fast that it's used as fuel to launch rockets to to the sky, right? So, but there are other reactions with oxygen that are less fast, such as how fast does an apple brown if you leave it on the counter? Well, it may take a while, of maybe a few seconds, several minutes, but it will eventually brown. That reaction is a reaction with oxygen. And eventually, all our human bodies will decay. Some of it is because of bacteria, but also some of it is because of the very exposure to oxygen, and we will combust slowly if bacteria do not do it faster. So you have here that different reactions take place differently. So why is that? Why is it that different chemical reactions take place at a different speed? Well, it's all related to how large of a barrier the reaction needs to surmount to reach products. One of the most common reactions that you will see in physiology is the hydrolysis of ATP. Um, it's sometimes is portrayed with a misconception, thinking that what gives off energy is the breaking of bonds. That is not true. Breaking chemical bonds will always require energy, and actually it will be the peak of this mountain, this energy mountain, that will need to be surmounted. What really gives off energy is the formation of the new bonds in the ADP and the free phosphate. So that's what gives off energy. So depending on the barrier that separates reactants and products, and also depending on how much energy do you give to reactants, the reaction will be faster or slower. So, and that's what we're trying to say, that we are two main factors that affect how fast reactions happen. One is the height of the barrier, and two is the initial energy. In the case of the rocket, the reaction takes place very fast. One, sure, the barrier is not very high, but also that one needs to provide a little bit of spark or fire. That's what actually preparing a fire is. You provide some heat so that the reaction has enough energy to surmount the barrier, and therefore the energy given off once it reaches products, it can feed back into reactants to keep giving energy so that you have an explosion as a product. Okay. So in general, you may be wondering, well, yeah, but I've seen that, for example, my sandwich, if you leave your sandwich on the counter, nothing will happen, and yet if you eat it, your body is able to catabolize it very fast. How can it be? Well, there are enzymes in our body that can lower the energy barrier. Again, your breakfast and the products are maybe the same, but sometimes in our case, the body can find ways around what would be a large energy barrier so that it can reach products faster. Okay, so again, the concept that we want to portray here is that the speed of the reaction depends on the height of the barrier, and that has nothing to do with how stable reactants are versus products. So in this case, for example, we are asking if you can identify which of these reactions will be fast and which of these will be exothermic or endothermic. Well, the ones that will be fast will be the ones with small barriers. So these two will be fast. However, the ones with larger barriers here will be slow. Okay, and that does not, being fast or slow does not mean that the products are more stable than the reactors or the other way around. As you can see, in this case is exothermic and in this case is endothermic, both cases being fast reactions. The same likewise here, this will be exothermic and this will be endothermic. Notice that the speed of the reaction, that is kinetics, does not mean is not related to thermodynamics and equilibrium that we will study in the next video. Those are two different things. Kinetics asks how fast, either slow or fast, and thermodynamics asks to what extent the products are more stable than the reactants, therefore we will obtain more of them. Okay?